let's look at what we did in subtraction. So we talked about the models, right? We talked about takeaway models. Yes, yes.
That's
Oh boy. Oh, and that's out. He always puts that out and doesn't bring it out. I think that's good, right? So we talked about takeaway model, right? We also talked about number line model. We know how to do that, right? Addition to the right, subtraction to the left. Missing additive model. We talked about that too. And from there we also talked about comparison model too. So we compare the blocks by matching the same number, right? And find the difference of the blocks. In fact family, if we have three numbers, we know the relationship, right? For example, 7 plus 5 is 12, 5 plus 7 is 12, 12 minus 7 is 5, 12 minus 5 equals 7. So we know the fact family too, right? And we have use practices with those levels within those steps. So now let's talk about the properties. Okay. Before we do that, let's quickly review what we did in the addition properties. What properties did we talk about in addition? What was the first thing that we did? In addition property. Of whole numbers. The first thing. Closer. Why do we check closer first? If it's not closed, if it's not a whole number, then we don't even have to talk about any other property. That's why we talk about closure first. So in the subtraction, let's talk about closure property if it works. Okay, so pick two whole numbers. 8 and 6. We have two whole numbers. Let's look at the subtraction. We are in subtraction. So let's look at subtraction. Okay. So 8 minus 6. 8 is a whole number, 6 is a whole number. Let's see the difference is also a whole number. What's 8 minus 6? Is it a whole number? Yes, it's a whole number. Let's look at the other way around. 6 minus 8. What is it? Negative 2. Is it a whole number? No, it's not. It's not a whole number. So what do we say about closure property? It's not closed, right? The closure property doesn't work. And do we even check commutative property, associative property, identity property? Do we have to check them? We don't even have to check them. Okay, because it's not closed in subtraction. Okay? Right. So we can check all of that. Okay. Can you find the solution for each of the following where x is a whole number? X is a whole number. So on your notebook, I want everybody to try these problems. Okay? So x plus 8 is equal to 13. What can x be? How would you find it? Would you use addition or subtraction? How about this? This x, 15 minus x equals 8. How would you find it? It is already subtraction, right? But I'm wondering if you are still using subtraction to find x. Just like the first problem. In the context, it shows that it is addition problem, but we actually add something? You may not. So I want to discuss about that, okay? And the rest of that. So I will give you about 2 minutes to solve all these four. Maybe little less than 2 minutes. 준비했던 이준열당. If you're struggling, show me your thumb down. If it is so, you're doing okay. Okay, let's do this together now. Okay, the first one is x plus 8 equals 13. X plus 8 equals 13. What is x? 1. How did you find that? Okay, one way you can subtract 8 to compensate that, right? So from balance beam, think about the balance beam. Equal is always balancing. So left hand side x plus 8 and right hand side 13, they are equal. It's balancing now. If I take away 8 from left hand side of the balance beam, so if you have a balance beam having x plus 8 here, and I have 13 of the same objects on the other side, it's balancing. If I take away these 8 away, it's not equal anymore, right? It's gonna slant. If 13 is heavier, you need to do the exactly same thing on the other side. That's the equal sign, right? So we need to do the exactly same thing. Then what we have left here is x equals what? 5. That's one way. Maybe some of you solve this differently. How did you solve differently? Anybody? Even if you didn't, can you think of a different way? Let's go back to addition, like missing addend. If we think this as missing addend, what can we do? We talked about counting on, right? How about going backwards, counting backwards? Can we do that too? So starting from 13, you start from 13 and go backwards by 8. 13, 12, I'm using my fingers, 12, 11, 10, 9, 8, 7, 6, right? And one more, 5. So I took away 8, and I have landed on what? 5. So that's another way too, right? So you can find, going backwards. Let's do it the other way. Addition part. Going backwards, 8 of them, and land on, land on at 5. You took away 8 of them there, right? So there should be some other ways too. Keep thinking about that. How about the second problem? 15 minus x equals 8. 15 minus x equals what? 8. How did you solve this problem?
Same way as
Okay, so tell me.
subtracted 15.
You
Or
subtracted
no.
15? We can do this
You
one
can
too.
subtract
yeah.
15 and then divide by negative 1 after.
Yeah, but we are on whole numbers now.
Right.
So if we already know about integers, if your students already know about integers, negative numbers, you can do that. But let's suppose they didn't learn that yet. Just like we didn't learn integers yet. So they only know the positive number. Then this is not very effective, right? Let's think about different way. How can we do that?
You said 15 minus 8.
You can do 15 minus 8 instead. Okay, to find x, because we know the relationship between these three numbers. In the triangle that we talked about, we have a 15, another number, and another number. And we know the relationship here. If we add that by 8, we can have 15, right? So we know a subtrahend and the difference added together, we can have, this is subtrahend, this is numend. Subtrahend is a number that is subtracted, and the number that is subtracting, so you are minusing it, that's called the numend. Okay, and the final answer for subtraction is called the difference. Right? So we know the relationship between these three numbers. If you add minuend and difference, you can get the subtrahend, the number that is subtracted. Right? So we can change that to addition situation, or we can use the number family. Right? That's another way. The third one, part C, is saying x is greater than 9 and x is less than 11. So your x is greater than 9 and, not or, x is less than 11. How would you solve this one? And again, x is a whole number. How would you solve this one?
Use the number line.
Both of you, okay. Use number line, okay, that's nice. So if we use number line, we are dealing with only the whole number. So let me put 8, 9, 10, and 11. So these are the whole numbers, and of course we have more numbers on both sides. Now I said x is, let's read this together. X is greater than 9. So from 9 is included or not? Not. So do we open it or close it? We open it because it's not included, right? So open it, which means not including that. It says x is greater. So what are those numbers, like 10, 11, 12, those numbers? So we are looking at the numbers on the right hand side, this side, only the whole numbers. Okay? And we have x is, let's read this one together too. X is less than 11. So 11 is here, and less than means numbers like this, so on the left hand side. And it says and, which means we need to look at the overlapping part. So which whole number is in between 9 and 11? Only 10, but these two are not included, right? So that only whole number should be 10. So number line is very useful, right? Okay. If you want to think about a different way, maybe you can do x is greater than 9. You can list them like 10, 11, 12, 13. You can list them. And then look at the next sentence. X is less than 11, which means less than 11. Only 10. So you can find that too. Okay, so always think about more than 2 ways. All right. How about the last one? X plus b equals a. X plus b equals a if a is greater than or equal to b and a and b are the whole numbers. Both of them are the whole numbers. You know this notation, right? The notation here. So I use lowercase for the elements and I use the capital letter for the set of whole numbers, right? So the relationship between elements and the set is this. If these two are the elements of this set. If not, you can just cross that out. Between the set, we use this notation, right? The side note. Anyways, okay, when a and b both are the whole numbers, x plus b is equal to a. And what do we need to find? We need to find what x is. How do you find the x? Yeah, just like the balance beam we talked about at the beginning. So think about the balance beam again. So I have x plus b on this side of balance beam, and I have a on the other side. So what we need to know is just the x. So you can take away b, right? Take b away, then you need to do the same thing on the other side to make the balance beam still flat. So x is equal to a minus b. You can do that. You can connect this idea to the algebraic thinking later and do, well, you can add the same number or subtract the same number on both sides. It hardly doesn't change. We can do x is equal to a minus b there. Or you can also think about fact family again. If we know these three numbers, we know the triangle here. The sum is a, and the other two numbers are x plus b. So we know x plus b is equal to a, b plus x is a minus b is x, a minus x is b. We know all the relationship there, right? So to find the x, we know that x is a minus b. So we can also use that family there in the different subtraction. Right? Okay, I think so far so good. Yeah, nothing's hard. Right. Okay. So now let's talk about the subtraction algorithm. So in addition algorithm, we also talked about using base 10 blocks, right? And we did a regrouping. Subtraction algorithm is the same thing. So we need to use the base 10 blocks too. Okay, so here is base 10 blocks. Where are you? So this is another virtual manipulatives that I found. I don't know which one's better. I'm just exploring. I think this is good because you can, use this material manipulatives here, and also you can write down the numbers there too. You can also change the colors for different place values. So I don't know. I like it. Let's think about 243 minus 61. 243 minus 61. The fact that I don't like about this manipulatives, it doesn't show the place values with the columns. Remember the other one, it shows the columns for each place value, ones, tens, hundreds, things like that. So in that sense, I like the other one more. But I just wanted to know all these things. So let's think about, wow, big. 200, 100, and 200. 40, 110, 10. It doesn't matter whether you use horizontal or vertical, right? 30, 40, 3, 242, 243. Now we need to take away 61. So let's take away 61. I just wanted to show what we are doing here, the thinking process. So I'm just gonna use my pencil to do it. To take away 61, what do you do first? You take away 1 first. So let's take that away. And you can see how many are left, right? There are 2 left. And to take away 60, we are looking at the tens place because we need to take away 6 rods. So let's take away 6. 1, 2, 3, 4. I'm talking about all these rods. So we took away 4 rods, but we need to still take away 2 more. So what do we do now? You need to take away 2 more rods from here, but it's stuck together. It's in the 100th place. So what we need to do is we have to regroup this, right? The good thing about this one, it helps me to regroup. Like that. They're exactly same amount. Now, instead of us having 100, we have 10 tens. Now I can take away 2 more from there, right? I'll take away 2 more. Another rod and another rod. Right? So I took away 6 rods. 1, 2, 3, 4, 5, 6 rods. Now, how many hundreds do we have left? We only have 100, right? 1 flat. And how many rods do I have? How many tens? 8 tens. and I have 2 units left. So that's pretty much what's going on in the algorithm, standard algorithm. So let's redo that part here. 243 minus 61 without the manipulative. We already have done that, so we know what's going on, right? So if you can subtract from one's place, we can do it. 3 minus 1, 2. We can take away 6 tenths from 4 tenths. So what we did is we regrouped that only one of the 100s, right? Leaving the first one there, so there's only 100 left. We regrouped, listen carefully, we regrouped 100 into how many tens? 10 tens. So when I write 10 there, I'm not gonna write it right above it because then it becomes another 1 tenth, right? So we have 10 tenths. So to indicate that, I'm gonna put it a little bit in front of 4. So it shows it's 14, not 4 and 1. You see that? So we now have 14 minus 6. What do we get? 8. We have 82, right? Let's compare this with addition algorithm. We said have 1 minus 0, 1 100. I want to compare this with addition. So let's go back. So we just did 243 minus 61. And let me redo that. When we were regrouping this, there's 100 left, and 100 changes into 10 tenths, so we put that in front of that. So this means it's 10 rods, right? So if we are adding, let me say number. If we are adding, let's see what's happening. Okay? 3 plus 1 is 4. 4 plus 6 is 10, right? So where do I put that 1 that carried over? In front of 2 or above 2? Above 2, because that is another 10, 10. 10, 10, you can regroup it as 1 100. So it's the same as that 100 place value, right? So you need to write it right above, not in front. Okay? So emphasize that with your students too. So even if this one means it's 1 100, this one means it's actually 10 tens. Okay? You see the difference? Okay. Yeah, the concepts that we are doing in 235, it's pretty much easy because you already know all about that. But let's always think about how we can teach our students. Okay? So always think about more precise way and also a lot of different strategies. Okay, that's what's going on. Here's another algorithm that we can think about. This is called the equal addition algorithm. I will let you read this and think about what's going on here instead of I just explain that to you. And I want somebody to explain this to the whole class. If you understand, hard to understand, come down. I want to see everybody's understanding. Show me your thumb, please. Can anybody explain what's going on here? Does it make sense to you? I actually wanted to talk about this compared to addition. So if we have an addition problem, let's say 93 plus, let's do 9. When we're doing that, We did a several ways, right? So one of the easiest way to solve this one, well, you can add 93 by 7, then you take away 7 from 9. Remember to compensate that? So we added one number to one of the addends, then we had to subtract the same amount from the other addends in addition. Compare that with this situation, 93 minus 9. What I do here is we have to add 7 here to number 3. Then I need to add 7 to 9 as well. Hey, previously if I had to add 7, I had to subtract 7. But now I'm adding 7 and adding 7 again. How does it work? Can anybody explain that? So let me read this again for you. Maybe if I write it this way, it makes more sense.
Then you have to balance it out.
You're balancing out. And how does it work? Because look at this. Minus is in front of the parentheses. What we can do is we can distribute the -1 to each of them. And what's happening here is 93 plus 7 minus 9 minus 7. So you can see that it's actually plus 7 minus 7. So we can cancel that out. It's not different from 93 minus 9. You see that? Yeah, because we are subtracting 9. Even if we are adding 7 to 9, we are actually subtracting 16. Does it make sense? That's why it works. It's exactly the same meaning. So when we are doing another example of 255 minus 163, let's look at the example. We are making this number easily. Because think about it. 260 minus 168 is easier for you, or 200, let me see, whatever the number is, minus 170 is easier. Which one's easier, this or that? Isn't this easier? So if you have something like something 0, tens or hundreds or thousands, taking away that much is so much easier, right? So what we want to change is we're gonna change the minuend with each number. Okay, so we can change this number to 170. 270. So what we did is we added 7, but actually we are subtracting 7 more there. That means we need to add 7 here too as well, right? Then what we have here is 262. So we can do 262 minus 170 instead of 255 minus 163. Then we don't have to deal so much about the regrouping. Okay, maybe a little less. So 2 minus 0 is so much easier. 2, and it helps your mental math too. 26 minus 17. 6. Oh my god. 9, isn't it? Yeah. So that's so much easier. Okay? Alright, that's what's happening. I can move back and forth like that. Okay, so subtraction algorithm, we can do the counting of algorithm. This is a strategy. I wouldn't say it's an algorithm even if our textbook says it's algorithm. And previous one too. Now this is saying that's its compensation strategy. Counting of strategy. I like this one so much too. So let's suppose you are subtracting 31 from 100. Let me show you how to do that. So we are taking away 100. We are taking away 31 from 100. In order to do that, what we can do here is starting from 31, you're gonna find it out how you can reach up to 100. So we are going backwards, right? So think about easy way. To reach to 100, I think, to me, it's easy to add this 9. And where do I go then? 40. And from 40, I can just add what to make 100? 60. That's so much easier. And then what is the difference then? How much I added, right? So that is 69. We know that from 31, if I add 69, I can get to 100. Okay? So missing atoms is really, really helpful. If you extend this to the number line, it's similar to this one. So instead of redoing 100 minus 31 and find out where we land, we don't want to skip 31 parts there backwards, right? It takes so much time. You can think about it this way. Starting from 31, how many skips do I have to make to 100? So from 31, I will go 9 more, and I go to 40. From 40, I can go to 60 more, right? Then going backwards, 100 minus what is equal to 31? 100 minus 69 is equal to 31. Then using the fact family, we can think about 100 minus 31 and 69 as well. Make sense? Okay, I will give you one more problem such as that. Think about 200. Let's do a little bit more harder one. About 214 minus 59. How would you solve this problem using adding up? Solve that on your notebook. And I will randomly call your name, so you need to show me how you did it. Let's use the counting up strategy. (214 minus 59). Once you are done, think about the comparable end. So you're going to change the 59 to an easy number. Okay? So let's think about both of the cases. Do we have any volunteer for counting up strategy? Very good.
So I took 59 and I added 1 to it.
Okay, so added a 1 and you get
60.
60.
And then I added 60 and 140.
140.
And then I got 200.
200.
And then I added 14 to that and got 214.
Excellent.
And
So
then
what
my
is
final
the
answer was
difference then?
155.
Here we go. So add all of these together. So your missing addend is 150 what?
5.
Okay, great job. Maybe some of you did it differently. You don't have to have exactly same as Reagan. Is there anybody who put different numbers in here? Anybody? Catherine? You have the same number?
Yeah, I did the same thing.
Anybody else? Hannah, you got the same number too? Gavin? All same numbers? No? You use these numbers too? Nobody has different number? Yes, I'm gonna make up the different number. How about this way? You definitely same thing, but you can also do like 59 plus. I can go 100 by adding 41. It's possible, right? And then I can add from 100. I can add what to make 214. 214. I can do that too. So when you add these two numbers together, it's still 155. So there are a lot of different ways to do the same strategy. Okay? All right. Now let's think about the comparable numbers. That means we're gonna change either subtrahend or minuend into easier number. Which one's easier for us to change? 214 to an easier number or 59 to an easier number? Which one's easier? We want to change the minuend, the latter number, that number we are taking away, because it's easier to take away 60 than take away 59, isn't it? So what we're gonna do here is we're gonna take away 60, oops, take away 60 instead of 59. Then what happens to the subtrahend? How do I change this number? 215 or 213? Come on, louder. 215. You are adding the same number because this is subtraction. If you add 1 to 59, that's actually you are subtracting that 1, right? Okay, so we are adding 1 to both minuend and subtrahend. So 250 minus 60, it's so much easier now, right? 5 minus 0, 5. 21 minus 6, 15, 155. Okay? We can also use 215 and 214 minus 15. You can also use standard algorithm. Let's practice one more time with the standard algorithm. We want to take away 9 from 4. Can we do that? So what do? We want to regroup 110 into what? 10 ones, right? Instead of 110, we're going to change that to 10 ones. So this one small one, we're going to write it right in front of 4, because it shows 14 now. Now we can subtract 9 from 14. What is it? 5. And there is no more ones left. So we need to take away 5 tens from no tens. So what do we do? Not borrowing, right? Because we're not going to pay back. We're going to regroup or trade one of the 100 into 10 tens, right? 10 tens now. So we have now 10 tens and take away 5 tens from that. We have 5 tens left. And we still have 1 left. Okay? So whenever I was talking about carrying over or regrouping, I really emphasize 100, 10 tens, 10 ones. Because we have to think about actual quantity there. Okay? So don't just say that, oh, we carried over 1 or we borrowed 1. Be precise what's going on there. Okay, so your students can understand that better. Okay, let's look at next slide. What I have now. Now we can do mental computation. Even the previous ones, it really helps us to do the mental computation, right? So let's think about some strategies. This is similar to addition. You can do breaking up and reducing. Breaking up, in another words, is decomposing, right? We are decomposing the number, right, into 2 parts or more to make it easier. Then you're gonna bridge them. For example, 67 minus 36, you can just take away 30 first. Again, when kids are doing the mental computation, they tend to do from the left to right instead of doing from right to left, right? That's different from standard algorithm. So from 63, just take away 30, and what do we get? From 67, take away 30. You get
37.
37, take away 6 more. 31. Yeah, that is called breaking and bridging. Trading off. Trading off, we already talked about this. It's compensation. So if we are adding here 1 more to 39, that's actually taking away 1 more, right? Because of the distributable property. So if we are adding 1 more to the minuend, we need to do the same thing to the subtrahend. So we can make it easier number. So instead of doing 71 minus 39, 72 minus 40. That's so much easier to do that mentally. So 72 minus 40 is 32. You can do that mentally, right? So that's trading off. Are we good so far? Okay. Then next one is dropping the zeros. If you have so many zeros, you can just ignore that and put them later, right? So instead of reading this as 8,700, we can say that, oh, 8,700 minus 500. So our unit can be something 100. Now we can do 87 minus 5. In parentheses, 100. How many hundreds are there? 87 minus 5 many. So 82, 100. Put those 2 zeros there, right? So that's another easy mental computation we do. So here are the problems that I want you to try. You have 2 problems, and I want you to think about all 3 strategies, okay? And talk with your neighbors about that. Maybe some strategy is better than the others, or certain question, it depending on, what question you have. So I want you to think about all these, think about all 3 strategies we talked about. If you have any other strategy, you can invent that too, because our students are so creative, they can always make up the, strategy, which is really creative and really good resource to teach from. Let's do this together actually. Okay, what's your strategy? No, how would you solve this one?
I actually didn't know other than the simple algorithm, because the numbers, like, you don't have to, not borrow, you don't have to regroup any of them.
Okay, cool.
I really don't know.
Okay, so you're gonna do 3679 minus 474, and you're gonna use the standard algorithm. Okay, help me with that.
It'd just be 5,
9 minus 4 is 5, 7 minus 7, 0
0,
tens, 6 minus 400 is
2.
200, and 3 minus 0, 3,000. You can do that, right, mentally, okay? That's one way, and the other way. Diana,
I'm still working on
I'll just
it. I
tell
did
you.
the wrong way.
That's fine, just tell me, just tell me what you wanna do. Let's do that together.
I wanted to add 6 to 474.
Okay, so,
To make it more easy.
yeah, let's take a look at that one. Now, what Rihanna wants to do is compensation. So she wants to add 6 to both of them. Then the minuend becomes so much easier number, right? So what we're gonna do here is 3,600 what? 85 minus 480. It is so much easier, right? You can already see that. I mean, you can even subtract this number from the left. There's nothing to regroup. Oops, sorry, where did I get the 4? Okay, so that's another way. And I want Hannah to think about different strategies. Shall we do missing items? What do you want to add to this number to reach up to 3,679 at the end. 26, I like it, and you get 500. Oh, we are getting so close, right? And we can jump really big from here. Like what? 1,000? Yeah. Then we have 3,500. We're getting very close, right? Now, what do we want to add? This 179 to get 3,679. So what's the missing element? We can just add these numbers together, right? So if I line that up, I think it's so much easier to calculate. But I have 26, 3,179. So I'm rewriting that. Let's add them together. 6 and 9 is 15, and that's 110. And that's 100, and that's 3,000. So it is 3,201, right? Okay, we cannot drop the zeros here, right? Okay, so yeah, those are the strategies. But for the last one here, 2,500 minus 700, the easiest one is dropping the zeros. So 2,500 minus 700 is 100. 1,800. We can put 1,800. Great job. Okay, let's see what else we have. This is just one of the examples, but we already have done a lot, so I think we are good. Let's just quickly talk about this. Okay. So let's do the mental math. A store is having a sale on jackets. A jacket is on sale for $197, less than the original price. The original price is $352. Wow, that's expensive. So we are taking 197 from that. So what operations do you do?
I added 3 to both of them to make 355 minus 200.
Oh, so you are using the compensation. I love that. So you add 3 to both numbers, right? So we have 355 minus 200. That's so much easier, isn't it? So 355 minus 200 is 155. Wow, that's a good sale. It's about 50%, isn't it? Okay, great job. And you can always check your answer. You can send that back. That's it for today, and you guys did a great job. So this homework, 3.3, is due Wednesday. Okay? And also, quiz 1 is due Wednesday. Okay? Alright, there are not many questions, and I think you're good. If you have any question while you are doing the homework, there's a button for Ask Instructor, or you can just shoot me an email.